Okay, in this video, we're going to kind of go over some practice calculating empirical and molecular formulas from percent composition. So this first one here, I've calculated the percent composition is 78.1% boron and 21.9% hydrogen. Here I have the atomic masses for each one. First thing you need to do is sort of treat those percentages as almost like they're the mass. So change 78.1% to 78.1 grams of boron. Now what I need to do is I need to convert that into moles. So I'm going to take boron and divide that by 10.81 grams per mole, and I'm going to divide hydrogen by 1.01, and I'm going to take my end result. What this means is that I'm going to be getting 7.22 moles of boron and 21.68 moles of hydrogen. Well, start with the one that's smaller, which happens to be 7.22. So I'm going to take 7.22 divided by 7.22, of course that's going to be 1. Then I'm going to take the other one and also divide it by the smallest, 7.22. That's going to work out to be 3. So now I know that the ratio of boron to hydrogen is going to be 1 to 3. 1 boron and 3 hydrogen, but of course we don't use 1 in our subscript, so that's boron trihydride, so BH3. All right, same idea here. I have my percentages. I'm going to first convert those into grams and then divide them by their gram molecular mass to figure out what their moles are. So 32.38 divided by this divided by that, and the end result for each of this is I'm going to figure out how many moles of each one I have. I'm going to have 1.41 moles of sodium, 0.71 moles of sulfur, and 2.81 moles of oxygen. Well, I'm going to start with the one that's smallest, which in this case happens to be sulfur. That one is going to be what everything else is going to get divided by. So 0.71 divided by 0.71 gives you 1. 2.81 divided by that, and 1.41 is going to give you 1.99 and 3.96. Now obviously there's going to be some slight little mistakes here in our measuring, but what I'm going to do with this is I'm going to essentially round that. 1.99 is going to be about 2. And then 3.96 is going to be about 4. So now I know my ratio between there. I'm going to have 2 sodium, 1 sulfur, and then of course 4 oxygens, but I'm going to rewrite that without that 1 in the subscript. So it's Na2SO4, sodium sulfate. All right, now I'm going to be doing this a little bit differently. I have the empirical formula, I have the molar mass right here, but I need to figure out the molecular formula. So what I'm going to do in this case right here is I'm going to take P2O5 and I'm going to figure out what the total molecular mass of that is. That's going to work out to be 141.94 grams per mole. So that's 2 times my number of phosphorus plus 5 times my number of oxygen. Now what I'm going to do is I'm going to take the total molar mass, 283.89, and I'm going to divide that by 141.94 to figure out how many times can this go into the total, the molar mass there. That's going to work out to be 2, so that's going to be P2O5 times my whole number multiplier of 2, so that's going to work out to be P4O10. Now I'm going to be looking for the molecular formula when I have the empirical formula and the formula mass, just like we did in the last one there. So CH, that's going to be 1 times 12.01 plus 1 times 1.0 is going to be 13.02. Now I'm going to figure out what the difference is between there. So the total formula mass is 78.110 atomic mass units divided by the empirical formula is going to give me 6. So the whole number multiplier is going to be 6. So that's going to work out to be C6H6. Now, this one's kind of another percent one there. 4.04 grams of nitrogen with 11.46 grams of oxygen, and I have my total formula mass. So let's figure that out. 4.04 grams of nitrogen divided by its molar mass, and 11.46 grams of oxygen divided by its molar mass. This one worked out to be 0.288, and this one's 0.716. This one is my smaller of the two, so I'm going to divide it by there, and the other one gets divided by that as well. Obviously, this one is 1, and this one's going to work out to be 2.49. Well, I'm going to round that, and you don't want to round this one down to 2. In this case, this is 2.5. What I really need to do is I need to get that to a whole number integer. So I'm going to multiply that essentially by 2. So the nearest, simplest, lowest common denominator, kind of in this case right here, is 2. So that gets me to 2 of nitrogen and 5 of oxygen. So that's N2O5. Now I'm going to figure out what's the molar mass of that. 2 times 14 plus 5 times 16 is 108.02, and if you look at my total molar mass is 108, so that's going to work out to be about 1. X in this case is going to be 1, so the final formula is going to be N2O5. So that is both the empirical and the molecular formula for this particular compound.